organic compounds. We're just going to like scratch the surface of organic compounds. There's a whole 2-semester class on that, and that's just the beginning. So chemists divide chemicals or compounds into 2 categories, organic and inorganic. And the word organic to a chemist does not have the same meaning that an environmentalist going shopping at the grocery store might think of as organic. Organic compounds come from living things, right? So an apple is organic whether or not you sprayed it with nasty pesticides. Okay? The apple is organic. It was alive, right? So organic compounds come from living things. Inorganic comes from non-living things in the environment. There's some other stuff in there. You can read that. Organic compounds are going to have carbon and hydrogen in them, and sometimes some other elements. But the key element is carbon. So organic compounds have carbon and hydrogen, and that's the important part. Carbon bonds are going to be covalent bonds, and carbon atoms always make 4 covalent bonds. They can form single, double, or triple bonds. They can bond with other carbon atoms or with other elements like hydrogen. And there are so many different organic compounds because carbon can make so many different complicated things. Make long chains. So here's an example of some organic compounds. So here we have 3 carbons in a row, right? Here we have 4 carbons, but there's a branch here. They're making a T. There's another compound where it's 4 carbons in a straight line. Here's 6 carbons playing Ring Around the Rosie, right? And then we could have double bonds or triple bonds. We can have some other elements in there as well. And these are just the little small guys. There's just so many different compounds. So we're going to be using suffixes "-ane", "-ine", and "-ine", and those tell us about the types of bonds. So if it says "-ane" at the end, like this one, propane, isobutane, cyclohexane, it only has single bonds between the carbons. If the name has "-ine" at the end, that means there's at least 1 double bond. If it has "-ine" at the end, there's at least 1 triple bond. And then when you've got other elements in there, then there's other patterns, and we're not going to worry about that. So we can take all compounds and we can divide them into inorganic and organic. We can take organic compounds and divide them into hydrocarbons, which should just be carbon and hydrogen, or functionalized hydrocarbons. So these have something special about them. So the hydrocarbons, only carbon and hydrogen, these are really useful as fuels because they contain a lot of stored chemical energy, and when you burn them, they create carbon dioxide and water. The air pollution that we end up with from burning these things is because we're not burning the pure substance. And then the carbon dioxide that's produced is just an unavoidable problem. So this is kind of what I just told you. If we only have single bonds, it's got "-ane" at the end. If it has double bonds, at least 1, "-ine", triple bond, "-ine". And so the names for these things are a base name that's related to the number of carbons, and this suffix which tells us about what kind of bonds there are. So these are the base names, and if you skip past the first 4, these are very much like those hydrate prefixes and the molecular compound prefixes, right? Penta, hexa, hepta, octa, nona, deca, same number meanings. So this is how many carbon atoms. So hexane is going to have 6 carbon atoms. Those first 3 are like, well, why didn't they? Well, they just didn't, and we can't change it now because everybody's used to this. So how do you remember those? there's methane, ethane, propane, butane, right? So methane I usually remember as one, but then the other three can get confusing, and so this is the mnemonic that I used when I was in college. Mom eats pickled bananas. I mean, I don't know, are pickled bananas even a thing?
I hope not.
You know what it means if mom's eating pickled bananas? You're getting a new sibling soon.
Oh, Lord.
Hopefully that.
We don't need that.
No, we don't. So that's 1, 2, 3, 4 carbons. So this is just showing us some different common hydrocarbons, and so we see there's, carbon and hydrogen. These are the space filling models, and this tells us what they're used for. What we see in these structural formulas that each of the carbon has 4 bonds. Down here, this carbon has 2 bonds with the other carbon and 1 bond each with the hydrogen, and so that's still 4 bonds. The functional group comes from the special character that specific atoms or groups of atoms give to the organic compound. And so we can form groups of organic compounds that have the same functional group, and those are families. Methanol and isopropanol are both members of the alcohol family because they both have this OH functional group. So this is methanol, it has 1 carbon. The ol part is because it's an alcohol. This is isopropanol. Prop means 3, right? So this one has 3 carbons. So you see how the names kind of go in there. These are some of the functional groups. And I want you to be able to recognize a couple of these. I want you to be able to recognize the alcohol family, the carboxylic acid, family, and the amine family. So the amine family is going to have nitrogen in it. The carboxylic acid family is going to have this double bond oxygen and an OH group. The alcohol family is going to have an OH group. There might be one question on the exam about this, but it's in the course outline of record, and so I am teaching you about it, right? That's what we're doing right now. Okay, so this would be a possible exam question. Draw the structural formula for nonane. Except I don't want to look at your drawings, so I would make it multiple choice and pick out the correct one. Well, what does the NON at the beginning tell us? 9 carbons. And the ANE tells us single bonds. Okay? Turns out there's actually a whole bunch of different nonanes, but we're just going to look at the straight chain. So we're going to have 9 carbons, 3, 4, 5, 6, 7, 8, 9. And people sometimes ask me, well, what's OChem like? Well, that's the math that you're going to run into OChem. It's counting carbons. There's a lot of counting of carbons. And then we have to have hydrogens in there so that all the carbons have 4 bonds. So if we just make bonds so that there's top and bottom, right and left, 4 for each carbon, and we're just going to fill in the missing places with hydrogens, which, gets a little tedious. I don't know why that became an N. Did it again. I really should shorten this one. It's really tedious. So you should be able to pick out that as the correct formula, or if I gave you that formula and gave you some names, you should be able to pick out the right name. It wouldn't be pentane, because that would be 5 carbons, and this one has 9 carbons. It wouldn't be nonene, E-N-E, because this is all single bonds. nonene would have a double bond, okay? Not gonna do anything tricky here. Some of these hydrocarbon names will pop up occasionally later on, and so you need to have a clue what they are. And then here's another kind of question: to which family does this compound belong? So we're looking at this part. That's the functional group, right? So if we go back to the table, this is the one that has that functional group. That's the carboxylic acid. Like I said, I'm only gonna ask you about 3, possibly: alcohols, carboxylic acids, and amines.